All right, well, welcome everyone. I am JJ. Let's tackle an example problem. So we're going to find what's our moment of inertia about our centroidal x prime and y prime axis. So two sets of calculations here for the area we have shown. A rectangle with a semicircle cut out of the edge of it. For us to do this, we're going to have to do two things in here. First, I'm going to have to use the parallel axis theorem. The parallel axis theorem tells us our moment of inertia about any axis I want to take a look at equals the moment of inertia about the centroid of a shape plus the distance between those two axes squared times the area of our shape. So for us, when we're doing Ix prime, this would be our moment of inertia about the center of the entire object. We'll have to break this into individual pieces. But for the entire object, it's our moment of inertia about the centroid of an individual piece plus our distance between the center of the entire object, center of the piece, squared times the area. We'll just do that for each piece in there. And then we'll do the same idea for our y. But if I'm trying to figure that out, what's my distance between the center of the entire object and the center of an individual piece? I need to know loosely where my centroid is at. So let's come in and I'm going to estimate that in here. I'm going to guess that my centroid is, actually let's not worry about it. I'm going to need to figure out x bar and y bar in here. We can label these. I'm going to estimate maybe that my y prime axis is about right here. To figure that out, I'm going to need to know what is my x bar. So we'll come in right here. What is this distance? X bar gets me from that y-axis to the y prime axis. For my y bar, I'm going to say my centroid is maybe somewhere right around here. So I would need to know what is this distance. Where that axis right there, that's my x prime axis. X prime. We'll leave it all the way over here. My centroidal x-axis goes through the centroid. I would need in here to figure that out. I need a y distance from the x-axis up. What's my y bar? Is where I'm going to go with that to try to solve that problem out. If I'm doing centroid, I can come in and make a centroid table, which conveniently we've already laid out to do that. So I'm breaking this up into a rectangle and a semicircle. We'll just go through and fill everything in for this. So the first thing we need is what's the area of each of these? Well, my rectangle will be 100 wide, 100 times base times height. If my radius is 30, the diameter all the way across is 60. 100 times 60. Or this is 6,000. For shape 2, our semicircle, area of a full circle is pi r squared. So for half of that, a semicircle, pi r squared over 2. But remember, it's negative. This is a hole that's cut out of our shape. So we're going to do negative pi times 60 squared, pi r squared over 2. Negative pi times 60 squared over 2 is going to get me that my centroid here, or my y tilde, my area is what I'm looking for, is 14 negative 1413.72. Adding those together, 6,000 minus 1413 is going to get me my total area is 4586.28. Then we can just continue with that. What is my, it looks like my headings got cut off in here. That's okay. We'll work with that. What is my x tilde is what this next column should say. X tilde in millimeters. Then what's my y tilde in millimeters? What's my x tilde a in millimeters cubed and y tilde a in millimeters cubed? So how we need to fill in the rest of our table. Let's move that up some so I'm not writing on the line in the table. X tilde a, y tilde a. Looks a little bit better. But so for my x tilde, my distance, I'm going to measure this. It's an x distance. So from the y-axis to the centroid of each piece. For my first shape, that would just be half the base. Half of 100 is 50. 100 over 2, 50. For this next one, I'm going to write it out down below because it's kind of a messier equation. So my x tilde for the semicircle is going to get me Well, I need to measure from that x-axis. My centroid from this, my formula tells me it's a y bar in here because it's oriented differently. But from the flat side into the semicircle, if we took that and rotated it or counterclockwise, we get this shape. We're not looking for an x in here. But I'm using 4r over 3 pi. So I first need to get, it measures from the flat side, I need to get from y to the flat side. That'd be 100. 100. And then from the flat side, I come back into this 4r over 3 pi. So minus 4 times the radius is 30 divided by 3 pi. Or this is going to get us 87.27. 87.27. So we can fill that in. 87.27, just using this equation here. I never have a sum of my x tilde, so I can cross that one off. My next ones are y tildes. So I'm measuring from the x-axis coming up, same direction as y bar. So in the y direction, to get from the x-axis to the centroid of shape 1, I'm just going to go half the height, half of 60. 60 over 2 is 30. For my semicircle, I just need to get to the center of the semicircle. Or that's just the radius in. This is R30. And I don't need to add that one up. Once I have those, I'm just multiplying columns together to finish this little bit up. So my x tilde a, 6,000 times 50 is 300,000. Negative 1413 times 87.27. Don't forget that negative, carry that in. We're going to get negative 123. Negative 123. 371.7. 371.7. And we do need to add this up. So 3,000 minus my second one, we're going to get 176,628. 176,628.3. Let's try to write that a little bit smaller and get it all in the box. 176,628.3. 176,628.3. Then we're going to repeat that for my y tilde a calculations. So I'm working with y tilde and my area. 6,000 times 30 is 180,000. 180,000. Negative 1413.72 times 30 is going to give me negative 4,211. Negative 4211.5. And adding these up, we're going to get to negative 137,588. Negative 137,588.9. I think I have a calculation mistake. Oh no, 42,000. That checks out. Okay, I was dropping a digit there. But we can work with this. I have everything I need to get my centroid locations. So my x bar should be the sum. Let's actually move this up here and use space a little bit better. My x bar calculation. X bar should be the sum of my x tilde a, 176,628.3, 176,628.3, divided by my total area, 4586.28, divided by 4586.28. Or my x bar works out to get me 38.51 millimeters. And doing the same thing for y bar, we will get y bar equals my total y tilde a, which shouldn't be negative, it should be positive here, 137,588.9. Y bar 137,588.9 divided by my total area, 4586.28, which will get me 30 millimeters. That one shouldn't come as a surprise. If I had 30 was my centroid location for every piece in here, my centroid for everything should also be at 30 then. Let's go ahead and work with that. I now know my centroid locations. I can come in and start trying to find what's my ix prime and ix, or an iy prime. As we're doing these, I'm just going to say, well, this is going to be shape 1 is positive minus shape 2 because it's negative. And then we'll treat each shape as a positive area. We're just subtracting out the entire moment of inertia for a negative shape. So for ix is going to get us ix1. So this will be my moment of inertia about the centroid of shape 1. That's our rectangle. I'm using base times height cubed over 12. So my base is 100 times my height is 60 cubed over 12 plus d squared a. But my distance from the centroid of shape 1 at 30 in the y direction to my centroid of the entire thing, 30, that's the same point. That's 0. So plus 0 squared times the area is 0. That's my moment of inertia for shape 1. I can go on and say, well, let's take a look at shape 2 then. So I want to do minus, because we know this entire thing is negative. And then what am I looking at in here? I'm going to put brackets in so I remember everything. But I'm saying for a semicircle, my y-axis is going perpendicular to the flat side, or my x-axis here that I'm working with is perpendicular. That correlates to the y prime axis in my table. So I want to take iy prime, pi r to the 4th over 8. So times pi times my radius, 30 to the 4th over 8. And again, plus d squared a. My distance, though, here, it's 30 for each term in here. For y tilde and y bar, that distance is 0 then. So my d squared a is 0. This is it for my ix prime. Which if I solve that out, we're going to get that ix prime is equal to 1.789 times 10 to the 6th times 10 to the 6th millimeters. I need this on a new line, don't I? 1.789 times 10 to the 6th millimeters to the 4th. Ix prime is 1.789 times 10 to the 6th millimeters to the 4th. And that would be our first answer in here. We'll repeat basically that same process for iy prime now. We already know our x bar distance, so we're going to be using the distance from this x bar to x tilde on everything to kind of finish this up. So my iy prime should be iy1 prime minus iy2 prime, or iy for our rectangle prime minus iy for the semicircle prime. Let's come in and get these. So for shape 1, we would have height times base cubed over 12. My height is 60. My base is 100. So 60 times 100 cubed over 12 plus d squared a. My distance here should be from x bar to x tilde. We could write that x bar minus x tilde squared. I would do this so that it always shows up as a positive in my calculator. It just avoids weird sign errors. So we'll do 50 x tilde minus x bar. So plus 50 minus 38.15 squared times my area, 6,000. That'd be one of my two pieces in here. I can subtract out from that because it's a negative piece. Negative minus my moment of inertia for shape 2, that semicircle. When we do this, though, again, we're going to treat our area as positive. So I get both halves, my I bar and d squared a, showing up as a negative. So I'm factoring a negative out here and treating everything inside my brackets then like it's positive. So minus my y-axis here goes parallel to the flat side of the semicircle. So I want to use, and here that would be my x prime axis goes parallel to the flat side of the semicircle. So I use pi eighths minus 8 over 9 pi r to the 4th. So times pi eighths minus 8 over 9 pi times our radius. The radius was 30. to the fourth. That's my I bar term. I'll add into that d squared a. So plus my d would be x tilde minus x bar, 87.27, 87.27 minus x bar, 38.51. D squared times our area. Again, we're treating it like it's positive because we factored our negative out right here. So times 1413.72. And adding all of that up, and I'd really encourage you, don't do that all in one go, unless you have a calculator that like does the pretty print. Some of the newer ones do that, where you can really visually see, does it look correct, rather than just guessing all of your parentheses. But this is going to get us to IY prime is equal to 3.739 times 10 to the 6th millimeters to the 4th. Pretty much anytime we work in millimeters, we're going to end up getting really ginormous numbers. Not always, but it's a pretty common thing to have huge I numbers if we are in millimeters. But it happens, just be aware of it. But hopefully this was a useful video for us. If it was, hit the like and subscribe buttons. Stick around, watch more videos. Let's get you in with JJ.